Hi everyone, in this video we are going to practice doing a couple different calculations converting between wavelength and frequency, okay? So by the end of this video, hopefully you very easily can go back and forth between wavelength and frequency. So let's start off with a very simple problem. A light has a frequency of 4.93 times 10 to the 14th hertz. What is the wavelength? All right, did you get an answer? Hopefully you did. The first thing you need to do is begin by identifying your variables. So this problem tells us that you have a frequency of 4.93 times 10 to the 14th hertz. So our formula to go between frequency and wavelength is really pretty straightforward. Basically, we just say that our wavelength is equal to our speed of light all over our frequency. Now, our speed of light never changes. If we're on Earth, it's 3 times 10 to the 8th meters per second. Okay, so that's what we've calculated it to be. That's our constant. So all we need to do is put our wavelength here. Speed of light, it goes on the top, 3 times 10 to the 8th meters per second. And we divide this out by our frequency, which is 4.93 times 10 to the 14th hertz. Now remember, hertz is equal to 1 over second, so we can do hertz here, or we could also just put in 1 over seconds. Either unit would be fine. And if we were to calculate this out properly, we would end up with a wavelength equal to something which is 6.08 times 10 to the negative 7th meters, which is kind of a garbage unit when we're talking about light. We usually like to put things in nanometers. So for every 1 meter, we know that we have 1 times 10 to the 9th nanometers, a lot of them. And so we could just translate this into something that's a little bit more useful. We would see that our wavelength is equal to 608 nanometers. Now, I didn't tell you to convert that to nanometers, so you wouldn't have had any way of knowing that, but that is usually what I would ask for on an exam or a homework problem. All right, moving on. A radio wave has a wavelength of 1 millimeter. What is its frequency? Go. All right, did you get an answer? Hopefully you did. This one is also fairly straightforward. What you have to do is just identify your variables. So it tells us that you have a wavelength of 1 millimeter, but right away you should be kind of like, oh geez, you know, there's a red flag going off. Millimeters is not a unit you want when we're doing these calculations. You need to get that unit in meters. So we know that there are 1,000 millimeters in every 1 meter, and so if we solve that out properly, we now know that we have a wavelength of 0.001 meters. Okay, so that's your wavelength. We're looking for frequency, so all we're going to do is take that formula that we used in the first one and just flip our frequency and wavelength. So now our frequency is equal to our speed of light over wavelength. Again, pretty straightforward. Speed of light, we're still on Earth, we're still in this universe, we haven't changed anything, so our frequency is still equal to 3 times 10 to the 8th, all meters per second, that's your unit, divided by your wavelength, which is your 0.001 meters. So if you put that in your calculator properly, you end up with a frequency that is equal to 3 times 10 to the 11th inverse seconds, and that's just a giant number. I wouldn't really expect you to convert that to anything more useful, but 3 times 10 to the 11th inverse seconds or hertz, okay? Either of those would be proper units. All right, let's try one more, but please note that this is different, all right? So now we're on planet Dorf, Bieberdorf, right? Ha ha ha. Okay, sorry. So planet Dorf, this is in a different universe, all right? We're no longer here. We've somehow magically gone to a different universe, and the speed of light has changed. So it's no longer 3 times 10 to the 8th meters per second. It is now 7.2 times 10 to the 12th meters per second. Now, what is the frequency of a 1 kilometer radio wave? Go. All right, did you get an answer? So this one was just slightly more challenging because I've changed something on you. Please note that if I ever do this again, it will be the same thing. I will straight up tell you, hey, we've changed the speed of light. We're no longer using that old speed of light constant. So what we need to do now for this problem is we need to identify our new variables. So I'm going to say C prime, so speed of light on this planet, whatever, is equal to 7.2 times 10 to the 12th meters per second. So that's our speed of light. Now we're trying to determine our frequency, but we've been given a wavelength, so our wavelength is equal to 1 kilometer. Just like we had to do in our previous problem, we absolutely need to get this out of kilometers and into meters. So the best way of doing that is just converting. So we know for every 1 kilometer we have 1,000 meters. So our wavelength is actually just 1,000 meters long, just, right? All right, so now, solving for frequency. Frequency is equal to speed of light over wavelength, but we're on a new planet, so it's going to be speed of light prime. And so here we go, we have 7.2 times 10 to the 12th meters per second, all dividing this out by 1,000 meters. And on this planet, in this universe, this frequency would be equal to 7.2 times 10 to the 9th inverse seconds, or hertz. That's it. pretty straightforward. You need to be able to go from frequency to wavelength, or yeah, frequency to wavelength, back and forth again. You need to be very comfortable with it, because in the next video we're actually going to start practicing how to do things with energy units, okay? So this needs to be very easy so that you can ramp it up a notch. Good luck, take care of yourself, have water.